Hey guys, welcome back to my brand new video. In this video, I'm going to be teaching you all about the chapter 9 matrices. Chapter 9, class 10 ICSE syllabus. So, the chapter 9, which is matrices, is, if you understand, it's not at all hard. You may get confused for the first time if you're seeing this video or learning this chapter for the first time. Then matrices can be confusing in the multiplication form. There are two types: addition or subtraction form, other is multiplication form. Okay, so uh, that'll come later. First of all, we're gonna see what is matrix. Okay, so what is matrix? Right, can you see? Okay, so what is matrix, guys? So matrix is, yeah, huh. So matrix is nothing but uh, rectangular arrangement of numbers arranged in rows and columns. Rows and columns, right? Rows and columns. So a rectangular arrangement of numbers of two times. A rectangle. What is matrix? A matrix is a rectangular arrangement of numbers. So basically, they're arranged in the form of rows and columns. The example is simple. Let me show you any one of the example. So, example, yeah. Example will be 5, 1. This is one example. One more, 5, 7, 2 and 1. This is one more example. And the other one will be 5, 2 and 3. This is another example. So 5, 1, this is 1, right? So 5, 1 is example. 5, 2, 3, no comma. 5, 2, 3, there is no comma between the numbers in the matrix. That was a mistake by me. So 5, 2, 7, 1. So what are these called? These are called just the rectangular arrangement of numbers in rows and columns. So what are these rows and columns? These are the order. Order order of matrix. Order of matrix. So what are these? What is this order of matrix? M into N. This is the order of matrix. So let's take an example of this over here. So we all know that line coming from here, this is known as column, this is known as row. So how many so M is based on the rows and N is based on the columns. So how many M and N's are there? So 2M and 2N. So 2 into 2. So M into N is 2 into 2. So there are 2 rows, 2 columns. Right. So 2 into 2 is the example. Okay. This one. Can you guess it, guys? It is 1 into 3. This one, 2 into 1. Right? So, yeah. So this is the order of matrix. Right? Okay, guys. So there are like types of metrics. Okay, there are different types of metrics. So let's do it. So yeah, types of metrics is kind of easy, not hard, but if you understand, it'll be very good. So types of metrics. Types of matrix. The first matrix is the square matrix. Okay, is the square matrix. So what is this square matrix? So basically there are two types of main, like literally main matrix, that is square matrix. Okay, square matrix. One more is non-square. Non-square, or this is not the perfect term, but this is for your understanding. This real name is rectangular matrix. Rectangular matrix. So in the square matrix, the columns, okay, the number of columns and rows are equal. The number of rows and the number of columns and rows are equal. The number of columns and rows are equal. In rectangular matrix, the number of rows is not equal. Okay. The number of rows is not equal to the number of columns. Okay. So the square matrix says that number of columns and the number of rows are equal, whereas in rectangular matrix, the number of rows is not equal to the number of columns. Let's take an example. Okay. So, as I showed you in the first beginning, but still, for your understand, let's just take one more example. Okay. So, the example of a square matrix. let's take square matrix, which is 2, 3, 5, 6. This one example, one more example, 7, 8, 0, 3, 4, 2, 1, 0, 9. So this is where the number of columns and the number of rows is are equal. So this is known as the square matrix. What about rectangular matrix? Let's see about that too. Okay, okay, guys. While erasing, I have to pause the video, or else this video will be too long because of this also. So never mind. Let's do that next time. So rectangular matrix example, right? So let's take 2, 3, sorry, 2. Have I forgotten how to write 3? Never mind. So 2, 3, one more. Let's take 3, 7, 8, 9. What is this? This is rectangular matrix. Why? Because this actually not a rectangular matrix. You guys got confused, huh? Simply. Then 9, 10, 11, well, just random numbers, bro. So these are called as rectangular matrix. Let me pause the video. So guys, as I said, the types of matrix, two types are over, the main two types, the square matrix and the rectangular matrix, right? So in the square matrix, there are more types of it, okay? And in rectangular matrix, there is only one type under it. That is also known as transpose of matrix. That is also a type which comes under rectangular matrix. So about the square matrix, there are about 5 types under the under the square matrix. So the first one is diagonal matrix. Okay, diagonal matrix. So what is this diagonal matrix? So diagonal matrix is a matrix where it is diagonal. Just say, yeah. For this, you need an example. So imagine 5, then -2, then 3. Others all are 0. Just imagine. This is known as principal axis. This thing. This thing is known as the principal axis. So if the principal axis has some numbers, random numbers, except the principal axis, all the others are zero, then it's called as diagonal matrix. So the perfect, not the perfect, but yeah, understandable definition for this diagonal matrix is, in a square matrix, all elements are zero except the principal diagonal elements. Understood? Finish. Easy. Throw it out. Okay. Uh, in this textbook, what is it given? So a square matrix, same, which has all its elements zero, each except those on leading or principal diagonal, is called diagonal matrix. The same thing, but in simple words. They've added some leading terms, zero, exit. This is more simpler. Yeah. In a square matrix, all elements are zero except principal diagonal elements. That's it. Almost same, but simpler. What? So you can copy whichever you want. I'll repeat once more. If you don't want my definition, you can just forward this. In square matrix, all elements are zero except the principal diagonal elements. Diagonal elements. So this is my definition. I hope nobody listened to it, but still, yeah, just for you guys. Okay, you understood this? Easy. It's not hard, right? Concentrate, guys, on your studies. It'll be everything will be easy, guys. Everything. And come home, practice it. Finish. Throw it up. Now after studying, throw it. No, no. Yeah. Then the second type is scalar matrix. So what is this scalar matrix over here? So scalar matrix is a matrix which is measured by the scale. Again, kidding. So a scalar matrix, you need an example for this. So this is the first example. This is the small second example. So this is 2, this 0, this 0, this 0, this 2, this 0, 0, 0, 2. And this is 5, this is 0, this is 5, sorry, 0, and this is 5. So in this both, what can you see? There's some similarity. Okay, leave this. In this, something similar, right? That is 2, 2, 2, and others is 0, 0, 0, 0, 0, 0, 0, 0. So the numbers which are same on the principal axis is known as scalar matrix. Understood? Easy. So my definition my definition is something like, here it comes. In diagonal matrix, all principal diagonal elements are same. Finish. Over. Khatam. Easy. So, see, if the numbers are same, all the numbers are same in the principal axis and the others are zero, all others are zero, then it's called as scalar matrix. Yeah, scalar matrix. Okay, then we have kind of important, it will be asked in your exams in a kind of like, you know, equation. Okay, it can be asked in an equation like 6i ai. What is I? So I is a symbol of I. I just read. I is a symbol of identity. Identity matrix. Doing this is fun now. Okay, never mind. So what is identity matrix over here, guys? So 1 0 0 0 0 1 0 0 1. This is identity matrix. Finish. When the principal axis has 1 1 1, when the numbers in the all the numbers in the principal axis is 1 and the others except the principal axis are 0, then it's called as identity matrix. This is 3 into 3. This is 2 into 2. That's it. Isa bacha. So 2 into 2, 3 into 3. But still, the principal axis has 1. All the numbers in the principal axis is 1, then it's called as identity matrix. Finish. So my definition is something like, in a diagonal matrix, all the principal diagonal elements are 1 and it is denoted by 1. Sorry. It is denoted by I. What is denoted by I? Identity matrix is denoted by I. What is I now? I is this. I is this. This. Let's see the definition in the book. A diagonal matrix in which each element of its leading diagonal is unity. That is 1. Is called a unit or identity matrix. It is denoted by I. In other words, it's a square matrix in which each element of its leading diagonal is equal to 1 and all other remaining elements of the matrix are 0 each. Okay. Okay, guys. Understood. Finish. Identity matrix. Finish. The number, the principal axis is 1. Okay. Then next is about the symmetric. Yeah, symmetric. 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 What is symmetric? Symmetric is building homes. Okay. No, I'm just kidding. Symmetric is Geometry. Got confused? It's kind of geometry only, but very interesting. Very kind of geometry, you know. So symmetric matrix. Symmetric matrix is a matrix if it if fold on a principal. This is my definition, okay? If fold on a principal axis, the same numbers fall on each other. Example. So look at this, guys. Here, here, excluding, so the numbers in the principal axis is totally random numbers. But other than that, the numbers which are here, except, so the numbers except the principal axis, if, okay, never mind. So I'll just give you an example, okay? Okay, this is a sheet of paper. Here is 1, 5, 7. Just imagine. Then 4, then 3, then 4, 3, then 6, 6. So it'll be 1, 4, 3, 4, 5, 6, 3, 6, 7. If I fold this on the principal axis, so this is a page and I fold it. Here is 4, here is 4. They fall on each other. Here is 4, here is 4. They fall on each other. 4 and 4. They fall on each other like this. 3, 3, 3, 3 at the corners. They fall on each other. 6, 6 at the end. 6, 6. They fall on each other. So this is known as the symmetric matrix, guys. Symmetric matrix. So next is skew symmetric matrix. What is skew symmetric matrix? It's simple, but I'll give you a break of 5 minutes, then we'll continue the session. Bye. So guys, I hope you finished your break. So we were in the types of matrix. So we finished 4 types of square matrix, right? So this is the 5th one, skew symmetric matrix. The last one was only symmetric matrix. This is skew symmetric matrix. Okay, so guys, the example for this, first we have to see the example. So the example for this. So the example is so it is 0 minus 4 Alright, so 0 minus 4, then 5. 4, 0, 6, then 0 minus 6 plus 5. So what is Q symmetric matrix? The example is this. It's this. It's almost same as the symmetric matrix, but there are two changes. That is, the numbers in the skew symmetric matrix will be -4, and this also should be -4. And when it falls together, it should be same. But here it is +4, one is +4 and one is -4. So these two are different, right? So if they fall on each other, the signs are totally different, right? And the numbers is also different because -4 is somewhere else, 4 is this side, and 0 is in the middle. So in the line. And in skew symmetry, the second difference is the principal axis is 0. The principal axis which is present, that will be 0. Okay. So the definition in my words are all number of principal axis is 0 if folded the other number fall on each, but the number which has different signs. So this is an example of it, and this is a definition of it. So what is the definition, guys? All number of principal axis is 0. Okay. If folded, the other number fall on each other, but the number which has different signs. Okay, the number which has different signs. Okay, understood? Number which has different signs. So this is the types of square matrix. Types of square matrix. Now there is one rectangular matrix. Okay, which is basically let me erase this. So guys, we finished the basics of matrix, right? I hope you all understood about this. Now we're gonna start doing the sums, example sums. So first of all, we're gonna start the subtraction and addition. Okay. subtraction and addition. So we'll take one example. Okay. So the example is sorry. The example is something like this, and x and 3 and y plus 2 and z minus 1, okay, equal to 1, 3, 2. This is the question. So what should we do here? First of all, this is first, for your reference, you have to always see the m into n. So what is m into n in this? So in this, first m into n is 2 into 2. 2 columns, 2 rows. Right? See, these were together. Okay, not different. So 2 into 2. Right? 2 into 2. And here also 2 into 2. Right? So what should we do here? They have given that we have to find x, y, z. You have to find x, y, and z. So what should we do here? First of all, add this to this, this to this, this to this, and this to this. Understood? This to this to this, 3 to 3, z minus 1 to 2. Understood? This is subtraction or addition method. The next one will be more simpler. This is just little easy, but at the same time little confusing. So x equals 3. So we don't have to take 3 over here. Like we don't need to find 3, right? We already know it's 3. We have to find, they have given x, y, z. So we'll take x, y plus 2 and z minus 1. So first, x one side, y plus 2 one side, and z minus 1 the other side. So what is x? It goes like this, it stops at 3. So x equals 3. Then y plus 2, it goes like this and stops at 1. So y plus 2 equals 1. Then z minus 1, it goes like this and stops at 2. So z minus 1 equals 2. X we already found it. Here 2 will go, plus 2 will go that side, it becomes minus 2. So equals 1 minus 2, answer will be minus 1. Right? Answer will be minus 1. Okay. Then here z minus 1 equal to 2. So minus 1 goes that side, becomes plus 1. So z equals 3 is our final answer. So we found x, which is 3, y, which is minus 1, and z, which is 3. Understood, guys? Easy. Okay. So this was one of the examples. The other example for the same thing is so my other question is 1, 5, 6. This is 8. 5, 1, right? So this is the one more question. So here, what we have to do, we have to, what is it given? Summation or subtraction of images. So we have to add over here. So A plus B. They have given A plus B equals how much? Right? Equals how much? That we have to find. So in this addition or subtraction method, this the first row, first column, 1 plus 2, 0 plus 5, 5 plus 1, 3 plus 3. Okay, it goes like that. So first of all, we'll write it in a proper way. So 1503 plus 153. Right? So if we add, we're gonna get 1, as I told, 1 plus 2. So 1 plus 2, write that 1 plus 2 over there. 0 plus 5. Okay, 0 plus 5. Give gap over here, or else it will be considered as these two are together, and you may lose marks. You may or not, you will lose marks, of course. So again, 5 plus 1, 3 plus 3. Right? Now, solve this. 2 plus 1, 5 plus 0, 5 plus 1, 3 plus 3. Is this your answer correct? That's it. This is addition. Okay, easy. We'll do one more sum, which is of subtraction. This is kind of little confusing, but it'll be very easy. Okay, as I expect. Guys, so what is it all about? One sec, please. So, yeah, the subtraction question is A, they are given 2, 4, 6, 3, 5, 7. So this is a rectangular matrix. Then B, they are given -4, 0, -1, 3, -2, 7. Right? That is the question. Now we'll write in a simple form. 2, 4, 6, 3, 5, 7 minus -4, 0, -1, 3, -2, 7. Right? This is our question. So what should we do here? We have to subtract, right? The same thing. Okay, the same thing. 2 minus 4. But 2 minus 4, but there is a minus before one more minus before the 4. So first minus, wait, so 2 minus into minus, first let's write 2 minus into minus, minus into minus gives us plus, minus into minus plus 4 as it is. Is that right? Right. Then 3 minus 3. Right? 4 minus 0. 5 minus into minus plus. Minus into minus plus. So 5 plus 2. 6 minus into minus plus 6 plus 1. 7 minus into minus into plus minus 7 minus 7. So what will you get the answer as? 2 plus 4, 6. 3 minus 3, 0. 4 minus 0, 4. 6 plus 1, 5 plus 2, 7 minus 7. This will be your answer. Is this correct? Okay. Understood? In this video, we are gonna finish the whole chapter of matrix. Not exactly full, but the examples and the multiplication. Multiplication we're gonna do more. After this finish, next is multiplication. It is very easy if you understand only. You may get confused for if you like try, you have to practice 20 times. The 10 other times you will get confused. That's for sure. It happened to me. The other 10 times it'll be perfect. It may just go out of track, but you can bring it back easily by using the trick. So guys, now we're gonna do multiplication of matrix. So what is this multiplication of matrix, guys? Multiplication of matrix. I will write it out. So the number of columns, number of columns in the first matrix is equal to the number of rows in the second matrix. Then A plus B can be multiplied. So the number of columns in the first matrix is equal to the number of rows in the second matrix, where after that then A plus B can be multiplied. Let me give you an example of this, how it's done, how the multiplication is done of matrix. Imagine this is one square matrix, which is X, Y, Z, A. Okay. And the other one is B, C, D, E. So here you have to remember only one thing, guys, which is this row, like this arrow or not. Why? This can make you remember till your final exam. Use this arrow method. This will be very helpful for you. If you forget, you won't forget because this arrow sign will be available in every question. Make a habit of keeping this, but after your 10th graduation and all, you go to POC, you need not put need to put the arrow. But for 10, this is important. This arrow, this indicates that X into B, X into B. Right? X into B. Correct? Right? X into B. Minus, or like plus, is based on the sign which you have. If this is minus, then you have to keep minus because plus into minus is minus. If it is minus or here also, then minus into minus plus. But here is nothing, so you just keep plus. So plus y into d, y into d. Okay. Then x, this is not finished. This is still there. So x into c now. Leave some gap. X into c plus y into e, y into e. Then this is finished. This is done. We have next is this. So z again into b. Take this. Z into d plus a into d. A into d. Z into c. Z into c and a into plus a into e. Understood? So this is how multiplication works. But before solving this thing, when you see the question of multiplication, first to verify your answer at the first, you have to write m into n, means the order of these two matrices. That is 2 into 2. This also 2 into 2. So 2 into 2 into 2 into 2. If the two middle terms in the center, if these two middle terms are equal, are same, then you will cancel it. Only these two in the center only. In the center only. Okay, then what is left? 2 into 2 is left. So you will get the answer into 2 into 2. So you multiply these two, you add, you multiply these two, you add one term. Multiply, multiply, add one term. Multiply, multiply, add, multiply, multiply, add. So how many terms? 1, 2, 3, 4. So you get just like imagine one Z C A. Just imagine, okay. This is your answer is 2 into 2. That is that is now the verification which is done at already in the at the beginning of the of your sum. Okay, so we're gonna do some more sums, but not in this video. Uh, it's already like 12. So I'm gonna like do a lot of multiplication sums tomorrow, and we're also going to finish the quadratic equation which are left in the middle. We have to do the sum and product of the root to find the sum and product of the root, right? So yeah, I hope you enjoyed this. We're gonna have more fun with more multiplication sums, and yeah, so that's it for today. I hope you enjoyed. Make sure you guys subscribe, and I'll meet you in the next video. Till then, take care, everyone, and bye bye. Peace out.